Bonsol. Bonsol, TLDR, is a proving network for Solana. Now that might sound crazy because what ZK is there on Solana and does it even need it? Well, the short answer is not really, not yet. There's some teams working on ZK. On Solana, I think the two most notable projects are Light Protocol working on state compression, another one being Bonsol, which is a co-led project jointly developed by Anagram and Zero Computing, and hopefully many others as well. And my job today is to try to convince you to come build with us on Bonsol. The way that we're thinking about Bonsol is to be a publicly verifiable computation good. Okay, that's a hand. Maybe it doesn't have the nice ring to it, but public VC goods for Solana. And really try.
Open the mic.
Yeah. Thank you. Okay, there we go. Check. Now, sorry. Okay. But yeah, it's to be public goods for Solana, and really trying to take a lot of the Ethereum kind of community-led innovation that's gone on and bring that to the Solana ecosystem. So why are we bullish on Bonsol? Well, first, ZK and verifiable, I should more broadly say verifiable computation is very new to Solana, but we think there's a lot of opportunities for it to be used. Really, it was just this past July where kind of Solana's equivalent of a precompile, its own syscall, got implemented that allows you to natively verify proofs on chain. And this should unlock a whole kind of new bunch of companies and applications to build verifiable computation applications, as state compression and off-chain computation being the two kind of broad categories so far. And we're also we think that Solana is built very differently from Ethereum, and so even though there's a lot of existing ZK infrastructure, mostly in the EVM space, we think people, especially core devs, will want to build Solana Solana first infrastructure. And also applications will want to build on top of Solana first infrastructure. And then we're very excited about these new markets and new types of applications this will unlock. So at a high level, where we're thinking this can go is, we have from DevCon the kind of hot topic was SVM rollups to unlock kind of like super low latency applications. Mostly were DeFi. But we see this as an opportunity to create this kind of OP stack, this kind of like built by the community for the community, kind of set of public goods that people can reuse and build on top of for Solana. And we're already seeing ideas of Solana being used to scale Ethereum and Bitcoin. Anatoly himself has he's maybe shit posted about Solana being the biggest Ethereum L2. But it's not implausible to think about Solana that way. And so, we can really just see it as like an extension, as a scaling mechanism of existing blockchains. And then there's also this idea of kind of AVSs and restaking, something that Jito is exploring. But it allows you to kind of piggyback off of existing work that the community is building. And as we said, we want to build this out in the open. And so the idea we were questioning at the beginning, like, does a foundation make sense? And where our heads are right now is that it does. We just believe that if this is going to be for the community, then a foundation should be created to support the development and innovation of it, and it should really be governed by many people, not just one company. And that's kind of the future we see for Bonsol and for ZK, hopefully on Solana, which is that it's built into profit sharing or to maximize profit sharing, rather than profit maximizing for one or two companies in the ecosystem. And we're taking a page out of Optimism's RGPF or RPGF playbook, but the idea is to retroactively fund projects that build useful things in Bonsol and on top of Bonsol. And so, we're hoping to create this flywheel effect of teams having some incentive to come and experiment on new things. And so, as such, we're starting this Bonsol collective. This essentially is a group of individuals and teams who are interested in building up this type of infrastructure. And again, we're trying to adhere to this philosophy that all of this should be done out in the open and tailored for Solana. And the idea is that Bonsol will be its own kind of self-sustaining machine after a while. Applications use Bonsol to generate proofs, so they consume proofs. Provers on Bonsol pick up those tasks, and the protocol earns fees as a kind of as a slice off the top, and then those fees are redistributed to those teams who had made those contributions to Bonsol. So what we're doing at Zero Computing is building kind of one demonstration of how teams can use verifiable compute on Solana. So we're building this game. It's called ZK Imposter, but it's super simple. And the novelty here is that it's the first kind of use of off-chain computation for a Solana application. So essentially, there's a bunch of players who register into a game onto a Solana program. They play the game logic. That game logic goes to this off-chain server to generate a proof, and the proof is then posted back on chain for the winner. And some beyond this kind of simple application, what we're seeing as some near-term opportunities is to, one, have a sustainable auction mechanism, or really marketplace for proofs, something that I think a lot of teams are trying to figure out, and is a very top of mind question, because if we're interested in building verifiable computation, whether that's validity proofs or ZK proofs, then we have to create a market that actually incentivizes both sides of the market, both provers and both supply and demand. And then we also see an opportunity to integrate essentially a variety of proving systems, a variety of ZK VMs, so that we don't need to put all of our eggs in one basket, and essentially it's up to the user to determine which proving system they want to use. So here's kind of where we're at on a roadmap. We had this idea of Bonsol, which is this off-chain compute framework for building verifiable computation. So essentially what it looks like is it's essentially you write a RISC-0 program, you publish it to Bonsol, which then any prover on the Bonsol network can access that ELF binary, that RISC-0 program. And then any application on top of it can create an execution request, essentially proof request, just put in their bid and their tip, and some prover in the network will pick it up and generate that proof. So that's what Bonsol is today. We're building these apps and SDKs on top of it. So this ZK Imposter game was one example of that. And we're trying to abstract more and more things away from developers, essentially making it easier for other teams to come in and build. And then building this foundation, which is we're still in the planning process of, but we want to get this out into the open as soon as possible and get people's input on how we should actually do this. So our core values for Bonsol is to first be designed for Solana, be built by the community, and when there's some sort of token launch for this, we want it to be as fair as possible, and so have no pre-allocations and airdrops. We just want it to be, essentially bring back trust into token launches. That's the gist of it. And again, it was kind of started by Anagram and Zero Computing, and then we have several awesome partners who are helping out Firma, the Proving Network, in how we can design essentially prover incentives, Fabric to be helping out on the kind of hardware underneath, and then Trident is a great hardware provider in the Solana ecosystem. And that's the gist of it. And I was thinking could go into some of the, what we're trying to do is as a part of this building out in the open, sharing how we're thinking about critical features. And so maybe two large topics that we're thinking about right now are essentially how provers can claim execution requests in the network, and then B, how execution requests or proof requests are actually priced in a network. So maybe it's just to start off with the easier one, a staking claiming mechanism. essentially what we have right now is provers have to stake this bond token in order to participate in the proving network. And the amount, essentially the types of jobs that they can pick up are proportional to the amount of stake that they have. So for example, for a very large execution request, for a very large proof, they have to have enough stake and therefore collateral to be able to pick that up. And then with smaller, so we think this is pretty straightforward. But yeah, this is how we're currently thinking about how provers can pick up jobs. And the way that proofs are actually priced in the market right now, from what we've seen in other markets, so like Boundless, it's not very transparent. You have essentially people, demand side applications putting in requests for proofs and offering to pay some price, and then it goes to risk zero, and they essentially cut up that program into a bunch of different batches and then segments, and then they send it out to their proving network. And it's not the most transparent way to allocate essentially revenue from proof generation. And then you also have teams like Succinct, who just released their proof contest white paper, and it's a pretty fair reverse auction mechanism. But the approach that we're trying to take is how can we actually estimate the real cost of generating proof rather than making it fully up to kind of like game theory. So our base. So essentially in Bonsol, there's this concept of base fee, which is kind of like the minimum amount. The minimum cost for some proof, and then a tip that you can add on top if, for example, there's two of the same proof requests in the market, and you want yours to get done faster. So the way that we're coming up with base fees right now is essentially a function of the size of the workload. Since we're using risk zero proofs right now, that'll be the number of clock cycles that is generated by the executor stats for that program. And then times essentially the cost of executing some number of cycles. So for example, the cost of executing 100,000 cycles of the risk zero VM proof. And with that, we come up with this kind of very simple cost estimation for the minimum amount that someone should pay for this proof. And then the idea is to make this dynamic based off of different network conditions. So we can turn this into a polynomial, add coefficients for different network conditions, and then have it be more kind of adjust to the activity of the network. So this is how we're thinking about these two things right now. And if you guys would love for you guys to poke holes in it and essentially just try and beat it up and try and make it better. Yeah, that's everything today. Thank you.